Alright, 3.4 here, solving analytically. This is part A. So just to recap, right, we got the derivative here. Remember, the derivative is just the slope. We got different ways that we can calculate it: numerical, graphical, like just looking and seeing, observing what the slope appears to be, looking and seeing, finding slope between 2 points, maybe take the average of a couple slopes, finding the slope, and then there's the analytical approach using the definition of derivative. Here we have the different definitions of derivatives. This is the formal one, but like I said, this is the one that we will usually use. Right here with the h instead of the delta x. Gone over those, so let's do a couple problems with it. Okay, so here they want us to find the derivative of sine of x. So we're going to do all the same stuff, plug it into our definition derivative formula, and just go from there. So what is f prime of x if f of x is sine x? Well, it's the limit as h approaches 0 of, and this would be sine of x plus h minus sine of x all over h. Well, I say it here in the notes, you need to have this formula to really let this thing work. So let's go ahead and expand it and see what happens. Still have the limit as h approaches 0, but now it would be sine x cosine h plus cosine x sine h, oh sorry, that should be an h, minus sine x all over h. Alright, with this you now have to start getting a little bit creative. And the thing that I notice is that there's a sine x in this term and in this term. So I'm going to group those together, and I'm going to separate it into two limits because we're allowed to do that. So check it out. I'm going to do the limit as h approaches 0 of sine x cosine h minus sine x. I'm going to put that over h, because if this is all over h, we could separate into common denominator fractions, or fractions with common denominators, plus the limit as h approaches 0 of cosine x sine h also over h. Okay, you're allowed to do that, right? I just took this part right here, moved it over here, made it a separate limit. If you think about this as one fraction over h, one thing over h, one thing over h, you can move it around as needed. And so I've moved it around like this. This is a very convenient way to move it because I can factor out a sine x here, and since there's no x in my limit notation, I can actually factor out the sine x all the way in front. So it would look like this. And over here, I could do the same thing with this cosine x. Okay, now we should have some limits that we can definitely evaluate. So, let's look at the left side here. We know what this limit is. This is one of our rules. This is actually when the limit of this approaches 0, we know that this whole thing is just 0. So really what I have here is sine of x times 0 plus, over here I have the cosine of x out in front, but what is this? We know what this is. This is just 1. So this is times 1. Well, all of this, we know what this equals now. Sine times 0 is just 0. So we don't even need that, and so this whole thing just equals cosine x. Ignore that little 3 there, that's just the page number. Okay. Alright, so that means the derivative of sine is cosine, and maybe in class we'll figure out what the derivative of cosine is. Kind of fun. Let's go to the next page. Okay, same thing here. Remember, I don't like using the delta x, so I'm just going to replace all the delta x's with h. You're allowed to do that. It's not a big deal. So let's use this definition to find the derivative of x cubed. Alright, so derivative of x cubed has to equal the limit as h approaches 0 of, now it's going to be x plus h cubed minus just x cubed all over h. Well, this is going to be a little bit trickier. How do we expand this? So in Algebra 2 you would have learned about this, but I'm going to kind of do a little review. This is what's called Pascal's triangle. And all I'm doing is I'm putting ones on the sides and I'm adding up the two numbers. So like 1 and 1 is 2. Right? So here I put a 1 on the side, 1 on the side. 1 and 2 is 3, and 2 and 1 is 3. And I could keep going with this 1, 4, 6, 4, 1. And this thing goes on and on forever. Well, this also gives us the coefficients of binomial expansions. So for example, this first row is like a binomial to the 0 power. This is like a binomial to the first power. And look, this is the pattern of a binomial or a perfect square. It would be 1a squared, 2ab plus 1b squared. And then here we have the coefficients to a cube. And so on, this would be for a fourth and so on. But we really only need this one because we're cubing x plus h. So what is this going to look like? Well, we know what it's going to look like now. We don't have to we don't got to do like box method or distribution or anything like that. We can just use Pascal's. So this is really going to look like 1x cubed plus 3x squared h. And notice the exponents just are going to go down each term for the x's and up each term for the h's. So this is actually like h to the 0. This is h to the 1, next one's going to be h squared, so it's going to be 3x to the 1, but h squared, and then plus h cubed. So see the pattern there? It's 1, 3, 3, 1, 1, 3, 3, 1. So that's a really quick way to expand a binomial. And then you also see that the exponents go 3, 2, 1, 0, or 0, 1, 2, 3. So this whole thing is over h. Oh, and I almost forgot. Remember, I'm subtracting this x cubed. Okay. Well, we can see that these x cubes cancel each other out. And we can rewrite this with the h factored out because there is an h in all of these terms here. So if I write the h out in front, it would look like 3x squared plus 3xh plus h squared all over h. And that's convenient. These h's cancel out. That's really nice because that was the only reason we couldn't just plug in for the limit, was that it would be over 0. So we're really just asking for the limit as h approaches 0 of 3x squared plus 3xh plus h squared. That's easy enough to evaluate. It is simply 3x squared plus 3x times 0 plus 0. Well, these both just turn into 0, so this ends up being all our derivative is. And so the derivative, or a function, remember the derivative is just like a function for slope. So the derivative for x cubed is 3x squared. So now we know the derivative for x cubed. Alright, we'll do some more fun ones on the next video. See you guys on the next one.